Hello there, this is question 51 of the exam practice medley. So this question is similar to the one that has the pile where you release the weight and the weight collide with another pile on which is stationary on the ground. So there is just one tricky point which I will discuss in a moment, but first of all, let's see what we are asked to do. We are asked to find the work done in pulling this mass up. Okay, so what we know for now is that initial velocity is 2 meters per second, and the final velocity is 3 meters per second, and we move through this mass by 5 meters. So what should we be finding? Well, first of all, let's look at work done. To find work done, we know the formula is force times distance. However, is this the only work done? Because if you think about it, apart from the mass and the distance that we need to move it to carry out the work, we are also working against another thing, which is the mass due to gravity. Okay, so therefore the work done isn't just force times distance, but it's also work done is due to the extra force which is here. So the force, not only is it due to MA, but also is due to the mg, and this is also the case when we did the pile question. So, but just this time is moving upwards rather than downwards. So please remember to add the mg as well, not just ma. So the question is, what do we need to find to get work done? Well, we can find force. We know the distance is going to be 5 meters. We need to move. Do we know accelerations? No. But do we know mass and the g? So the only thing we need to find before we can work out the work done is the acceleration. So based on this, it gives us a hint that this is related to Suvet. So we're going to use Suvet to find out which formula that we need to use. So first of all, we know S, we know U, we know V, and we are asked, we really want to find acceleration. We are not given time, so let's see if we have enough variable to calculate the A. Well, just to let you know, in BTEC Level 3 Unit 1 exam, they tend to, and this regularly going to be applied in most exam question when it's Suvet, is the V square equal to U square plus 2AS. So I do recommend in the exam you look at this equation first, because it's most likely is this one. Because the reason they chose this is a very good one to see if the pupil can rearrange formulae. So obviously we now need to find A, so we need to make A the subject. So if you're not confident in making the subject a formula at this point, so I would suggest you substitute the numbers first. So let's put V square, which is 3 square, U square is 2 square, plus 2 lots of A times S, which is 5. So bit maths, so we do 5 times 2, 10, and then 10a. So this is just a simple equations, linear equation to solve. I think all of you at this stage in the year 12 should find this not quite straightforward. So let's take away 4 on both sides. So that leaves me with 5 is equal to 10a. So acceleration therefore is 5 over 10, or half meter per second square. Okay, so now we got A, we have everything now, so we then can go ahead and to find F. So force is mass. Now I can be a bit clever and bring this M outside the bracket and then say M times A plus M times G, like so. And so M is the mass of the weight, so it's 30 times 0.5 we just worked out plus 9.81. Okay, so if you don't know what G is, refer to the formula sheets. But at this stage, you should know what G is equal to. So let's bring the calculator up. So let's start by adding 0.5 with 9.81. And then multiply this answer by 30. And I will get 309.3 Newton. So then I would multiply to get work done this answer times the distance, which is 309.3 multiplied by the distance, which is 5. So times this by 5. One 546.5. Remember, work done is in joules. So, and this is the correct answer in the mark scheme. So there you have it.